Hello everyone, this is Mike, Backwards Machining. Well, something interesting happening anyway. John Strange asked me if I could make some gears, and you know what, it sounded like a fun video and something to try, so here we go. Basically, one of another YouTuber, Eddie, is looking for some gears for his Atlas lathe. So what I did was I downloaded from Thingiverse the gears. So I had to figure out what diametral pitch they were. So what I did was I downloaded the files from Thingiverse, and then I put it on here, 32 tooth, just pick one, it doesn't really matter. And you know, here is the gear for the lathe. It's got a 3/4 inch hole in the center and 2 keyed. I think that's 3/16, but I'd have to double check. Now, what I did was I went to FreeCAD's other feature here. It has a gear tab. You can bring a gear in and put in the diametral pitch of, you know, what you want, and then compare the two. And that's where I found out that these are a diametral pitch of 16 via doing it like this. So the next step is going to be, we're going to 3D print one of these, and then I'm going to try to make one out of aluminum, and let's see how it goes. Now, I have gear cutters, but not for a diametral pitch of 16. I've got bigger cutters for like 8, 10, and 12. But you can actually make a gear cutter pretty easily for aluminum. Steel, not so much. I mean, people do it. I don't know if I'd try it the way I'm doing it with steel. But anyway, here we go. Alright, this is one of the gears for Eddie. Looks like it came out pretty good. This way I can verify the diametral pitch and make sure my tool's right. This is the tool I made to do the gear cutting. And it works good. Believe it or not, this is actually for my Logan for this gear. So what I'm going to have to do is grind another one of these for this pitch for 16. I think this is 14, because that obviously it's a little bigger. So I'm going to bring this to work tomorrow, and I'm going to grind this in. That way I have a DP14 cutter. Okay, so I 3D printed out this gear that's supposed to be for a 10-inch Atlas lathe. This is, I forget how many teeth. I think 30. It's not important. What is important is this cutter. Basically, what I did was I cut the profile out. Not sure how well you guys can see that, but this should help me to make the aluminum gear. Let's see how it goes. All right. There's the tool. Time to set up the workpiece. All right. Let's see what happens. good to me. Alright, so now that we're set up, what we need to do is figure out the angle of which we're going to have to turn this 4th axis. Now, this is a 32 tooth gear that we're mimicking. So, all I'm going to do is divide 360 degrees divided by 32 teeth equals 11.25 degrees. So, what we're going to do, G00 A 11.25. Let me remove this lock just in case. Now, when we hit the button, it should move what we need. Alright. So, if calculations are correct, and let's just assume they're not, that should be the next tooth. Let's see what happens. So anyway, I just wrapped it right into there. That was not pretty. Luckily the cutter's still okay. But boy, that was an interesting show, let me tell you. Alright, I have it feeding now. It's going slow. I don't know if I damaged my cutter at all. Alright, it's starting to hit now. In this clip here, because I messed up and did a rapid command and the cutter slammed into the part and I didn't stop it quick enough, I flipped the part around just to see if it was going to work again. And as I was doing this, you can actually watch the body, the big body of the cutter start to wobble. And this is when I realized the wall thickness of that R8 collet is just too thin and that cutter's too heavy, which is why I changed things up. Basically, this is what I found out during this process. Alright, little design flaw in my tool here that I made. Unfortunately, using a 1-inch chuck or a 1-inch collet is not the most rigid. This thing has very small wall thickness, and it's basically beating the hell out of it, and it's actually moving in the collet no matter how tight I try to get this. So what I'm going to have to do is make a different tool, something that goes in a smaller collet, or maybe one of these beefier ones. That way I don't have to worry about it moving on me. So this is the tool that I made to go into the collet, and unfortunately, like I said, its main design flaw is this shank diameter. I should have never went with a 1-inch diameter. These collets are inherently just bad. Let me take it out so you can see it. And I mean, you can see how flimsy that is. Maybe for some light, very light duty milling, but definitely not for what I'm trying to use it for. I mean, you could see the slipping. So I am going to turn this down and see if that fixes the problem. I might also try to make this a little bit lighter. This thing is massive, it's heavy, and that's causing a lot of wear on that. So if I can make this lighter by reducing some of the mass, I think that'll help as well. So I'm going to need to do this before I can try to make this gear. What to do. So I'm thinking about making my own cutter. Basically, this is what a gear cutter looks like. So if I was to use this, which bear in mind, this is tool steel. And if I cut a little slice, round it down, put the angles on, and then mill out the notches, I'm thinking that might be a better cutter than trying to do the hammering thing. I mean, this is working, but if I do this, I can make it out of steel too. Huh. Which way will he go, George? All right, 3/4 inch shank, stainless steel, 316 body. Now I have to machine the top of this, and we will be good to go. So as I was explaining in the other part of this, I could go one of two ways. This is obviously the same design as I was going, except this will be a little easier to throw around, and it'll be in a much stronger collet. I also have this. Now, this would probably be the best solution to the problem, but I'm going to save this for last, because this is also going to be the trickiest, I believe, to do, because this is tool steel. Well, it's tool steel that's not hardened yet. This is I'm not sure if this is water or air hardened. I'll have to look. But anyway, I'm going to do this first. And what I'm going to do, because obviously all fly cutters have that angle, and you don't want an angle on a gear cutter, but I'm still going to make it look like this. So you have the part that's going to hold the bit, and this part here, that'll be taken away for the set screws. All right. All right. This is flush. So next is going to be, we're going to mill this part off. Basically, make it for the set screws. And we're going to be good to go. I think this video is getting long enough though. So, over the weekend, you should see some hardcore gear cutting action with no more dumb rapid feeds and other mishaps. Alright. See you guys later.